Hello, ladies and gentlemen. Welcome back to math. Today we're going to continue working on those polar forms. Okay. So far we learned how to solve for a complex number. Okay, equation. We went from rectangular form to polar form and vice versa. We learned how to solve for a polar form using multiplication and using division. Okay. Today we're going to continue it going. Today we're going to learn about exponents. Okay, when it comes to polar form. Okay, obviously we're going to solve for it, and then we're going to convert it into rectangular form, like we've been doing in the last few concepts. So our objective for today is to solve for a polar equation that has an exponent, then convert it to rectangular form. Okay, the reason why we want to get familiar with converting it is because we have to graph it later on. Remember, so far we've learned about conversion, about solving using exponents, and multiplication, division, converting to rectangular form. Very soon, obviously, we're going to keep it going all the way to the end of the year with these kind of concepts. But the thing we need to cover in the next few ones is about graphing. Okay, so that's what we need to get familiar with, converting it from polar to rectangular so we can graph it, and vice versa. Sometimes I might give you a rectangular form or a graph. You have to convert to rectangular, then convert it to polar form. Okay. So here's our equation for today. Okay, it's similar. It's still kind of the basic skeleton setup. Okay, the foundation of it is still the same. We still have cosine, we have I of sine, we have our r on the outside. Okay, the only thing that changes today is when dealing with an exponent. Okay, the n is our exponent. Okay, meaning that if we have an equation with an exponent, we have to square our radius times that number. Okay, we also have to multiply the number of your cosine, okay, times your exponent for cosine and sine. Okay, meaning if we have a problem like this, let's just purple. (60 degrees) plus I sine. Obviously, it's the same one, 60 degrees, to the exponent of 2. Okay? So we have 2 times cosine of 60 degrees plus I sine of 60 degrees to the second power. Okay? That means that we're going to use that second power and put it next to the r as an exponent. So we have 2 to the power of 2. Okay, cosine of 60 degrees times 2, okay, plus I sine of 60 degrees times 2. Okay, so we have 2 to the second power, another way of saying 2 times 2, which is 4. Okay, so we have 4 cosine 60 times 2. We can do it that way, where we can multiply the degree, or we can also skip a step by converting the 60 into the cosine and the sine. It's up to you. Okay, I'm going to do it this way just to do those extra steps so everybody can understand it really good. So I'm going to multiply 60 degrees times 2. 60 times 60 is 120 degrees. So cosine of 120 degrees plus I sine of 120 degrees. Okay. So now let's look at the unit circle. Let's see if we have 120 degrees on the unit circle. which look at that. We do have 120 degrees. Okay, 120 degrees. We have cosine and sine. Cosine of negative 1/2. So we can say 4. And then instead of cosine of 1/2, we have negative 1/2 plus radical of 3 over 2. Okay, don't forget the I. So we convert it, okay, or to our cosine and sine. So now we have 4 times negative 1 is negative 4. Negative 4 over 2 plus 4 to the radical of 3 over 2i. Okay. Again, 2 could go into 4 since it's negative. One's positive, one's negative. The answer is negative. So 2 can go into 4 2 times. So negative 2. Negative 2 plus 4. Well, look at that. 2 can go into 4 2 times. So technically it becomes 2 radical of 3i. Okay. So our answer is negative 2 plus 2 radical of 3i. Okay. Alright. So let's do one more just to get the practice of it. Make sure you have this one on your notes. Alright, the next one is we have 4 cosine of pi over 2 minus I sine of pi over 2, okay, to the third power. Okay? Keep in mind, guys, since we have a third power, we're going to say 4 to the third power cosine, change the radical, there we go, cosine of pi over 2, okay, pi over 2 times 3, okay, 3 over 1 minus I sine of pi over 2 times 3 over 1. Okay? I'm going to keep it as pi over 2. You could have converted if you wanted to 90 degrees. It's up to you. You can say 90 times 3. Okay? Again, there's different ways to do it. 4 to the third power is like saying 4 times 4 times 4. So 4 times 4 is 16. So let's do it up here. 16 times 4, we have 24, we have 2, 4, 5, 6. So we have 64. Okay? So we have 64 cosine of 3 pi over 2. Okay? Because 1, there's a 1 in front of the pi. 1 times 3 is 3. 2 times 1 is 2. Minus I sine of 3 pi over 2, again, which technically which technically 3 pi over 2, it's on the unit circle. 3 pi over 2 is down here. It's 270 degrees. So we have our sine and our cosine for 270 degrees. Cosine is 0, sine is negative 1. So we can say 64, 0, in this case is minus minus 1I. Remember, negative and negative makes it positive. So technically we're going to get rid of this, make this a plus. So we have 1I, or I. So 64 times 0 is 0, so there's nothing there. 64 times 1 is just 64. So we say 64 I is our answer. And that's it. Okay? Keep in mind, guys, again, there's different ways to solve it. Again, you can convert the pi over 2 to 90 degrees. Okay, if you wanted to. And then convert it once you solve for that extra piece. Okay? Alright. So again, make sure you have it on your notes. Alright, so here's your assignment for today. Remember, we're not only solving it, because our goal or our objective was not only to solve for the equation, but also convert it, which is what we're doing at the end. We're converting it. Okay? So here's your examples for today. Or your problems. 2 cosine of 30 degrees plus I sine of 30 degrees to the power of 3. Okay? And your second one is 1 cosine pi minus I sine pi to the power of 5. Okay? Remember, guys, make sure you submit your answers as soon as you're done watching the video, and I'll be here waiting for your email.